Good day, I'm Griselda van Wyk, and today I will be speaking about the human ear. Right, I'm going to start by telling you what I based my presentations on. Firstly, I based my presentation on the exam guideline. I hope that all of your teachers have given you an exam guideline. If you do not have this, you'll have to go to the DBE website to see if you can find the grade 12 exam guideline. Right, so that's the first part. The second part is not reflected on this slide. That is the diagnostic report that the DBE writes every year after the final exams. What happens is the internal moderators, those are the people that make sure that the papers are of a good standard every year, they write a report after the marking session to say what the learners struggled with and what the teachers now must teach. So I've worked that into the presentation. So when I get to slides that is not on the exam guideline, I will tell you that this slide is based on the diagnostic report. But let's have a look at the exam guideline, what you need to know about the ear. And just remember one thing, that the exam guideline is extremely important if you are a grade 12 learner. This guideline is used when examiners are setting the exam papers every year. They use this document. So if I can give you advice, use this while you are studying, because sometimes the textbooks won't have all of this content in there, or sometimes the textbooks have too much content. So this is like a guideline that you can use to see that you've studied the correct content, and you can tick it off as you go along. So let's look at what the guideline wants to know about the ear. Right, so the first bullet there is structure of the human ear and the functions of the different parts using a diagram. In life sciences, diagram is everything. Right, you have to know your diagram. So you'll see in this presentation that we have a lot of diagrams. The second bullet there is functioning of the human ear in hearing, including the role of the organ of Corti without details of its structure. Balance, include the role of the macula and crista without details of their structure. We will get into that detail as we go on. The last bullet there is cause and treatment of the following hearing defects: middle ear infections, use of grommets, and deafness, use of hearing aids and cochlear implants. So that is what we will be looking at today. So what do you need to know? The first unit in this presentation is about the structure of the ear. The second unit is the path of the sound through the ear. The third, balance and equilibrium. And the fourth, diseases and disorders of the ear. So let's just jump straight in, and we start with unit 1. Now if you look at this diagram, it's the structure of the ear. Now, I know most of you think the ear is only this meaty flap here on the side of your head, eh? You only thought, well, this is the ear. Well, clearly not. If you look at that structure there, there's quite a lot going on in your ear. Right, so this part here is part of the outer ear. You'll see there's 3 regions. The outer ear, which is colored in pink here. The middle ear, I colored it in yellow. And the blue part will be the inner ear. Right, so if we look at the outer ear, it will be the pinna. That's now the fleshy part here. The part your parents usually say, why aren't you using this? Is this an ornament? Why aren't you listening to me? Well, that's the pinna. Right. Then you've got your canal here. It's an auditory canal. I know we usually call it an ear canal, but look at that picture there. You'll see there's a lot of tubes and stuff going on there, a lot of canals. You can't call it an ear canal, because which one? There's a lot of them, right? So you have to call it the auditory canal. And the auditory canal comes from the word audio, right? So auditory is from audio, auditory canal. Then you've got your tympanic membrane. Tympanic membrane is the scientific word for the eardrum. Please don't call it the eardrum. Remember, this is a science and we are using scientific terminology. Right, the middle ear's got 3 little bones. We'll get into the detail just now, but it's called the malleus, incus, and stapes. It sounds very important. It is. Right, and you've got a little tube down there, the Eustachian tube. And then the blue part here looks like a little snail. Now, the antennas of this little cell is called the semicircular canals, right? And semicircular means half circles. You can see it looks like half circles, and there are 3 of them, right? And then you've got this little cochlea, that's a snail shell. It looks like a snail shell. And you've got the auditory nerve, right? So this blue part here is the inner ear. You've got your yellow part, which is the middle ear, and you've got the pink part, that's the outer ear. So there's lots more going on in your ear than you ever thought. But let's go into the detail now. Right, the outer ear, the structure and function. Remember, when you're studying for life sciences, always look at the diagrams, look at the labels, and look at the function. Now, the first part, like I said, it's the pinna, right? And this is the part that you all usually use to put studs and rings and stuff in, but it actually has a function. The function of the pinna is to direct sound waves into your ear. As you can see there. So it will direct the sound waves. It's actually catching the sound waves and directing it into your ear, right? The auditory canal will transmit the sound waves into the ear towards the tympanic membrane. It also has cerumen glands which secrete cerumen. Now, cerumen is wax. Now, we need earwax for the following reasons. There's a lot of dust particles and pollen and stuff floating around in the air. Now, imagine if you were 40 years old and you didn't have wax in your ear. What would happen? You would have this like huge dust pile in your ear, isn't it? It would be like dusty in there and you wouldn't be able to hear anything. So what the wax does, it's catching these little bits of dust and pollen and stuff, and it can come out of your ear. So it keeps your ear clean. It also keeps it moisturized, right? And as well as the tympanic membrane, it keeps it moisturized. And also there's little hairs inside your auditory canal that also helps to trap this little dust parts and stuff so that you can keep your ear clean. Right. The tympanic membrane, or your eardrum, as you know it, is used to, it vibrates and it transmits the sound into the middle ear. So that's the function of the tympanic membrane. And when your parents told you when you were small, I hope somebody told you, you shouldn't be putting foreign objects or sharp objects into your ear. The reason was, if you put pointy things into your ear, you can easily damage this tympanic membrane. You can actually tear it, and it will be extremely painful. I know there's some of you who have done it, so you can actually agree with me on that point. So never ever put sharp, pointy things in your ear, okay? There's a reason for that. And that was the outer ear. How easy was that? Now we get to the middle ear. This is a bit more complicated, but much more fascinating. Right, the middle ear, as you can see in this diagram here, it's composed of a space, an opening there. It's filled with air. It's got 3 little bones there, and like I said, the Eustachian tube. Now, those 3 little bones are called the ossicles. And ossicles is a term that's used for very small bones. These bones are extremely small. They are the smallest bones in your body. They can actually fit onto your fingerprint, just your fingertip. Just have a look at that picture there, that photo there. You can see how small they are and how cute they are. Right. Now, the names of these little bones comes from the way they look. If you look at them, the first one there looks like a little hammer. Right, looks like a little hammer. The middle one looks like an anvil. Now, an anvil was something that blacksmiths used in the olden days. Those were the people who took iron, they melted it, it was very hot, and then they hammered it into shape, right, into different shapes that you needed. And that table they used was an anvil. So you can see there's the anvil there. And look at that little bone there. It looks exactly like an anvil. And the last one there is a stirrup, or a stapes. And that's a part, if you've watched TV or you are riding horses yourself, that's the part where you put your foot in when you do horse riding. It's a footrest. And if you look at the shape of it here, it's exactly the same shape as that little bone there. So that's where the names came from. So you have your normal everyday names, hammer, anvil, stirrup, right? But we prefer that you use the scientific names. Malleus, which is hammer, incus, which is anvil, and stapes, which is stirrup, right? And if you want to remember or get a way to remember in which order these bones are sequenced, you can always use MIS, M-I-S, malleus, incus, stapes, right? So what's the function of these little bones? They've got a huge function in your ear. Firstly, they will transmit the vibrations from your tympanic membrane there, your eardrum, towards the inner ear. Right, so they transmit the vibrations from here to there. That's the first function they have. And the second function they have is they amplify the sound. Amplification means making louder, making the noise louder. Some of you who are DJs or having the sound systems at home, you have amplifiers in your sound system. Now, you've got everybody here, every human on earth has a little amplifier in their heads. It's called ossicles, right? So, like I said, the function is to amplify and transmit these vibrations to the inner ear. Now we get to a slide that was recommended by the Diagnostic Report. It's not in the exam guideline, and most probably it's not in your textbooks. So this is a very important slide that you need to maybe take a photo of or take notes of. And this is how do these ossicles amplify the sound. Very importantly, firstly, if you look at this diagram here, you can see there's the malleus, the incus, and the stapes. I've made little circles around the tympanic membrane. This is a tympanic membrane, and that's the oval window there where the stapes is. Right. Look how small it is in comparison to the tympanic membrane. At the bottom diagram, you can see they actually stretch it out to make it easier for you to see. You'll see the area of the tympanic membrane is much bigger than the oval window. Right, so that helps in amplification because the vibrations of this big, huge area, surface area is then concentrated on a very small area. Right, and that amplifies the sound. The second way in which it amplifies the sound is that if you look at these ossicles, look how big the malleus is, look how big the incus is, look how small the stapes is. So it is ordered from big to small. And that also helps to amplify the sound, right? So those are the ways in which the ossicles will amplify the sound. It actually amplifies it more than 20 times in the ear, so that the sound that reaches the oval window is 20 times more amplified or bigger than it was at the tympanic membrane. Remember this slide? It's from the Diagnostic Report. Okay, so it's important. It's not in the exam guideline, but they can ask it, and they have asked it in the past. Right, and that's not all that's in the middle ear. Now we get to the Eustachian tube. Eustachian tube, right. Now that Eustachian tube is not EU. You need that Eustachian tube. It's got a very important function in your ear. It connects your middle ear with your throat. It opens up at the back of your throat, right? And what it does, firstly, it drains any fluid that's in your middle ear. So if there's any inflammation or something, that liquid that forms can drain out into your throat, very importantly. So it doesn't build up there. And secondly, it maintains the pressure on both sides of the tympanic membrane. Right. What that means is the following. If this is your tympanic membrane, right, it can vibrate. It has to vibrate. This is your auditory canal, and this is your middle ear. The pressure on both sides of your tympanic membrane must be the same. If the pressure in the auditory canal is more than the pressure of the middle ear, what will happen? It will push in on the tympanic membrane, and that will cause a lot of pain, believe me. And also, will it be able to vibrate as nicely? No, it won't. So that's where the Eustachian tube comes in. If there's an imbalance in the pressure on both sides of this tympanic membrane, air can be let in or out of the middle ear to increase or decrease the air pressure within the middle ear and to balance it out so that the pressure from this side is the same as the pressure from this side. Right, and then your little tympanic membrane can vibrate its little heart out. Right, and you can see that I've bolded the either side of the tympanic membrane. When they ask this in the exams, please don't say the function of the Eustachian tube is to equalize pressure. You will not be awarded the mark. You have to say either sides of the tympanic membrane. Right, it's what air pressure. You have to be very specific to say which air pressure is it equalizing. And this is the application questions that they can ask on the Eustachian tube. The first one is scuba diving. Now that's me a couple of years ago when I was still thin. Scuba diving. Now the first thing that they teach you when you are a scuba diver is how to equalize. Because what happens is when you go down into the ocean, the sea, about here 1 meter, between 1 meter and 2 meters, that water pressure increases so much on your body that it impacts on your tympanic membrane. It hurts like crazy. So what you have to do, let me just explain why. Here's your tympanic membrane, right? Here's the pressure from the water. The pressure from the water now increases. The middle ear is still at the same pressure that it was when you were in the boat on top of the water, right? So that pressure didn't change. It's the same still there. But this pressure is now increasing, so it's pushing in on your tympanic membrane, causing a lot of pain. So what they teach you to do is to close your nose like this and to blow like this. And when you do that, just do it softly at home now. Don't do it all the way because you can maybe burst your tympanic membrane. You just slowly blow in your nose. You will feel the pressure going into your ears. What happens is you blow in your nose and the nasal cavity, the air is pushed into your throat through the Eustachian tube upwards into your middle ear. So what happens now is this is the tympanic membrane, air is being pushed in the middle ear and the pressure then stabilizes, right? And now the pressure is the same on both sides of the tympanic membrane, and that's equalization. And you have to do that many times as you go down into the ocean because the water pressure keeps on increasing. The second one is an aeroplane. So when you go into an aeroplane, it's the opposite effect than you have at scuba diving. When you go to a higher altitude, the air pressure decreases. Right, so what do we have here now? We have a tympanic membrane, we have our auditory canal, but now the pressure is decreasing, right? But the pressure in the middle ear is still the same as it was on the ground. So now the pressure here will start pushing this tympanic membrane outwards, right? Because this air pressure is decreasing here. And that also causes a lot of pain. So what you do now is you yawn like that. And or you chew a chappy, or you do this. And what you do is you're forcing air out of the Eustachian tube, out of the middle ear into your throat. And then it stabilizes the pressure again. It equalizes the pressure on both sides of your tympanic membrane. And then it can vibrate again, and everybody's happy, nobody's crying. So those are two application questions that you can get on the Eustachian tube. Right, now we get to the inner ear. Now the inner ear is a bit more complicated. As you see, it looks like a little snail there. It is a bony structure. This whole structure here is bony, but it's filled with liquid. Remember, the middle ear was filled with air as well as the outer ear, but this one is filled with liquid. So firstly, we have the oval window over there. Right, now the oval window is a membrane that has to vibrate. Okay, it was just like the tympanic membrane, it vibrates. It's carrying on vibrations into the liquid of the inner ear. Secondly, we have our semicircular canals. There's 3 of them, like I said, and they are arranged perpendicular to each other in different directions, 3 of them, right? And they've got little bubbles here at the bottom, and those little bubbles or bulbs at the bottom is called ampulla. And the ampulla contains a little receptor we call crista. We'll get into the detail of what they do a little bit later, but you just need to know that this is where the crista is found. Thirdly, we get the Utriculus and the Succulus. Now those are found in the middle here, between the semicircular canals and the cochlea. Right. Now, as you can see, the Utriculus, if you look at the diagram, the Utriculus is the top part and the Succulus is the bottom part. It's a little sac there at the bottom. Right. They are found in the middle between the semicircular canals and the cochlea. They also contain liquid, and they contain a little receptor we call the macula, also to do with balance, and we'll get into that later. Right, the fourth thing that you can find in the inner ear is the cochlea. That's a snail-like structure. It's filled with liquid. It contains the receptors for hearing. We call them the organ of Corti. Very important name, organ of Corti. The organ of Corti will be stimulated, and the stimuli will be converted into nerve impulses. Right, so that's the function of the receptors, the organ of Corti. The fifth structure we find is the round window. That's a little one here. Just below the oval window, there's a little round window there. Now, what the round window does is it releases the pressure in the liquid of the cochlea. Right. Think of the following scenario. There's liquid within the cochlea. So the oval window is causing waves within this cochlea. And if those waves are allowed to reflect again, it will distort the other waves in the liquid. Let me take an everyday example. If you carry a bucket of water, now you're carrying that bucket of water and the water is making little waves. Those waves don't stand there stationary. No, they move. And as they move, they bounce against the side of the bucket and they come back. And as they come back, they interfere with those little waves going there. So it's distortion, there's interference, right? We do not want that situation in our ears because you will have echoes. Somebody would say hello and you would say, hello, hello, hello. It would be like that the whole time. It would be horrible, right? So what happens is this round window will also vibrate and release these waves out of the liquid, and it will make sure that there's no echoes and no distortion of sound. So you need that little guy there. The last one of the inner ear is the auditory nerve. Now the auditory nerve is composed of two branches of nerves. The first one is coming here from this side, the vestibular nerve, and the second one is the cochlear nerve, is from here, the hearing one and the balance one. You don't need to know those names at all. All you need to know is the auditory nerve. That's it, that's what you need to know. Aren't you lucky? Two names you don't need to know. So now that we've finished with the structure and functions of the ear, I want to direct your attention to Mind the Gap study guide. I hope all of you have one. If you do not have one, just go to this website, and if you also don't have a grade 12 exam guideline, you can also use this website, www.education.gov.za. Go and have a look if you can find the grade 12 Mind the Gap, right? On page 129, you will find this template. This is how you study life sciences. As you can see, this is the outer ear, the middle ear, and the inner ear. So what do you have to do? You have to go and label each of them, all the structures that I've spoken about now, and write in the functions next to them. If you do that, you only have to use this template to study the ear, right? And remember, you have to know that because when we get to hearing now and balance, if you do not know the structures, how will you be able to understand the other functions of the ear? Right. So let's go to unit number 2, and that is now how do we hear, the path of sound through the ear. Now, if you look at this diagram, you can see that it starts with sound waves. Sound moves through waves, through the air, through water, and when it reaches your ear, what does the pinna do? I've already said that. It directs the sound waves into the auditory canal. Right, there it is. You can see there's a little waves going into the auditory canal. The moment it gets to the tympanic membrane, it knocks against this tympanic membrane. So when it touches the tympanic membrane, it moves, right? Moves in and out. So it depends on the frequency of sound, how fast it will be moving, or how loud it is, how big the vibrations will be. But this tympanic membrane will then start vibrating. Right, but what is connected to this tympanic membrane? The ossicles, of course. So onto this tympanic membrane, you will get your first ossicle, the malleus, the little hammer, right? So when it moves in, it will go like this, right? And when the hammer moves, or the malleus moves, the incus will move, right? And when the incus moves, what will happen to the stapes? The stapes will move. So these little three bones in that picture there, they work like levers. They're a system of levers, and they vibrate, right? They carry the vibration from the tympanic membrane all the way to the oval window, because the stapes, the last one, is connected to the oval window. So now when we get to the oval window, this oval window is now vibrating just as the tympanic membrane is vibrating, right? But now there's an important difference. All this happened in air. Now we are going to liquid, because there's liquid within the inner ear. So this vibrating oval window is causing waves inside this liquid. And we call those waves pressure waves. Pressure waves, right. So pressure waves are formed within this liquid, and they are moving throughout the cochlea, right? They're moving inside the cochlea. And with this movement of liquids causes the organ of Corti to be stimulated. And when it's stimulated, it converts the stimuli into a nerve impulse, right? Very important part, that if you can remember that part, converts a stimuli into a nerve impulse. That's one mark already. You can forget all the names and everything. If you can't remember anything, you've struck a blank there. Just remember this: stimuli converts stimuli into impulse. That's one mark, right? And what happens to that nerve impulse? Obviously, it's being transmitted via the auditory nerve to the cerebrum, the brain. But I don't want you to call it the brain. You must call it the cerebrum, because the cerebrum is the one that interprets sound so that you can hear. No other part of the brain, the cerebrum. So you have to be specific here. You must name it the cerebrum, not the brain. Okay, so if we just have to sum it up here, you will see we've got the pinna, and you can see what I've done is I've made the first letter of each word red so that we can make a mnemonic of it. There's a pinna, auditory canal, tympanic membrane. Pinna, auditory canal, tympanic membrane. That's the order. Pat, pinna, auditory canal, tympanic membrane, right? The middle part, malleus, incus, stapes, miss. Pat, miss. Oval window, cochlea, OC. Oval window, cochlea. Organ of Corti, I made it the C. Auditory nerve, cerebrum, CAC. Yes, I know some people will now say I'm teaching you to swear in Afrikaans. I'm not, because this is not how you spell that terrible word in Afrikaans. Okay, it's wrong spelling for that swear word, so it's not swearing. So our mnemonic will be pat, miss, OC, CAC. Pat, miss, OC, CAC. If you can remember that, you will remember sound. You will remember how to hear. Pat, miss, OC, CAC. And now you're not swearing. Right, so that is sound. And now we're going to get into a little bit more detail. Now, this is for the learners out there that wants to know, but why? This but why is not required by the exam guideline. So I'm telling you now, this part is, but if you look at the pictures, the diagrams, I just want to explain to you why. But it's not in the exam papers, all right? So let's look at that diagram at the top. If you look at the diagram at the top, you will see it's the cochlea that they've sort of cut in half, right? It's cut in half, so you can see it from the side. And you can see there's liquid in there. They call it the perilymph and the endolymph. There's 3 canals. The 3 canals are filled with liquid, right? So that's how the sound travels, in that liquid there, from the oval window. Now let's go to the bottom diagram there. And I just want to show you how the round window works. So if you look at the oval window here on top, in the top part of the structure, you will see that this tape is now vibrating, right? The oval window is vibrating. You can see the dotted lines are showing the pressure waves. So there's pressure waves, and they are moving inside of the top tube or the top canal. Now, if you look at this top canal here, you will see that there's a little membrane at the bottom. That membrane, because of the pressure in the liquid, the pressure wave, it is forced downwards. And you can see, if you look at those dotted lines, that's where it goes to. It's forced downwards, right? That causes, in turn, pressure in the middle canal, right? And that pressure in the middle canal pushes down onto that little membrane there, which moves down and causes the pressure to be transmitted into the bottom canal. So that pressure wave is then transmitted into the bottom canal, and that pressure wave moves to the round window. So what does the round window do? It also vibrates. Can you see where the dotted lines are at the round window? It's on the outside. So as the oval window goes in, the round window goes out. Right, so they vibrate like this. So the round window gets rid of those pressure waves in that manner. Right, and just for interest's sake, this is the organ of Corti. That increase in pressure there forces it downwards, and that's where the impulse, the stimulus is for the impulse to be made. But you do not need to know that. This detail was just for those learners who are a bit more curious. Let's see what you need to know. And this is what is asked in the exams. Right, this part here. Firstly, you need to know that the oval window vibrates. It causes pressure waves, right? Pressure waves in the fluid or the liquid of the cochlea. The organ of Corti is so important, that word, organ of Corti, is stimulated. Stimulus is converted into nerve impulse. Sure, that's 1 mark. People, you must know that sentence. Stimulus is converted into impulse. The nerve impulse is carried via the auditory nerve. That's always 1 mark as well, right? And it's taken to the cerebrum. You don't get a mark for the brain. You have to say the cerebrum. Right, this is sound, how you hear. The round window vibrates to release the pressure in the fluid. You see, you don't have to explain how it works. You just know it releases the pressure waves. Okay, this is what you need to know. This can count anything from 4 to 5 marks in the exam. This is another slide that was recommended by the Diagnostic Report. It's not in the exam guideline, but please, this is so important. Last year when we were marking, this was also emphasized to us markers. And that's the following. When you have the noise, it travels through sound waves. And those sound waves are directed by the pinna into the auditory canal. So when you have sound waves, it's this too. You talk about sound waves from the pinna to the ear, not the ear canal, the auditory canal. But the moment it gets to the tympanic membrane there, it's no longer a sound wave. You're not allowed to say sound wave anymore. Now you have to talk about vibrations, right? So this is a vibration, the ossicles vibrate, the oval window vibrates. So all of them vibrates, right? All of them vibrates. You cannot talk about sound waves here. If you say the ossicles transmits the sound waves, you will not get any marks. And that has happened in the past. So you have to say vibrates. And then the last part there, the moment you get to the cochlear fluid, you are talking about pressure waves. You're no longer talking about sound waves or vibrations. There's no vibrations there. There are pressure waves there. And if you talk about the organ of Corti, you have to say the pressure waves in the liquid will stimulate the organ of Corti, right? You cannot talk about the sound waves. You cannot talk about vibrations because there's no vibrations there, okay? And from the organ of Corti, it converts it into a nerve impulse. Very important, you have to say nerve impulse. Impulse is the key word there. And people, there are no messages here. This is not a WhatsApp. There's no WhatsApps here. No messages, please. I don't want to see any messages. And we see this every year. There's a message here and a message there. The ossicles are passing the message through to the cochlea's message here, and then it goes to the brain. No, there's no messages here. They cannot type. Right. So you talk about sound waves, vibrations, and pressure waves. And obviously the nerve impulses. This is an important slide. Like I said, it was recommended by DBE in the diagnostic report. Right, so please take a photo of this slide or make a note of this slide. Please make sure that you know the difference between these. Let's look at a couple of questions from past papers. Right, so there's your picture. And hopefully when you have your paper in front of you, you will know that that's the ear. I hope you don't think that is the bladder or the eye or the male reproductive system or something like that. No, you must know your structures in your diagram. Right, that's an ear. Okay, so let's look. Give one function of part A. So where's part A? There's part A. What is this called? The auditory canal. What does that do? It will transmit the sound waves to the tympanic membrane, or if you say secretes earwax. Both is correct. E, where's E? Here's E. I've spoken a lot about E. That's your Eustachian tube. But they're not asking what is the structure's name. They're asking what is the function. So we just talk about the function, right? And the function is to equalize the pressure on either side of the tympanic membrane. Can you see I bolded that either side? If you said equalize pressure, you would have received 0 marks, nothing. I would not give you marks. What pressure? Where are you equalizing pressure? There's a lot of pressure out there. What pressure did you equalize? Right. F. Look at F. F is that little round thingy there at the bottom of the inner ear. That would be the round window. And what does the round window do? We just spoke about it. It releases the pressure from the inner ear. So you don't have to go into details. Just say releases the pressure from the inner ear or prevent echoes in the ear or sound distortions in the ear. Let's look at another question. Number 2, same diagram. Write down only the letter of the part where the sound is transmitted in the form of a pressure wave in a liquid. Do you remember I told you that you need to know where the different things are? Pressure wave in a liquid. The only part that there's a liquid in this ear is there, right, in the inner ear. So it will be in the cochlea, number C. Can you write cochlea there? No. They said letter. If you write cochlea there, 0. Sorry for you, you cannot read apparently because the question said letter. It didn't say just write the name. You must read your questions. So it's C, right? An electrical impulse. Only place that can be is at the nerve there, the auditory canal. And that's D. Do not write auditory nerve, please. Next question, same diagram. Explain the effect if the receptors in region C are damaged. Now, where's region C? There it is, the cochlea. Which receptors are there? Only the organ of Corti. What do? They convert the stimuli into a nerve impulse, which is carried by the nerve. So already you know if that is damaged, what won't happen? The stimuli won't be converted. Yeah, so when damaged, the receptors cannot convert the stimuli into impulses. No impulses are transmitted to the cerebrum. Can you see? Cerebrum, not brain, cerebrum. And the person does not hear anything, or there's hearing lost, or hearing impaired. Next question. Same diagram. Describe how the parts of the middle ear, including the membranes, assist in amplifying sound. Aha! This one, this was taken from paper November 2018, and they found that children couldn't answer this question, and that's why it was in the diagnostic report. Remember I told you about the amplification, the ossicles, right? How do they amplify the sound? Right? It's something to do with the tympanic membrane. There. The ossicles transmit the vibrations from the large tympanic membrane to the smaller oval window, and that concentrates the vibrations on this small surface area, which amplifies them. Right. So this is important. This is an important question. You have to go and have a look at this one. Right. That's to do with the diagnostic report. So, it's not all from the same paper. What I've done is I've taken the diagram and I've added questions from different years so that we can, you can have all the difficult ones together. Explain why fusion of the structures at B may lead to hearing loss. This was also mentioned in a diagnostic report, this one here. This one. It's not in the textbooks. It's not in the exam guideline. So they wrote that we must please teachers, please teach your learners this. Right. So B is again the ossicles. Now let's think about it. They work like levers, hey. Now if they become fused, which means they are stuck together, they cannot move at all. They're like, boop, there they are. There's no movement now. So now they cannot vibrate. And if they cannot vibrate, they cannot pass the vibrations to the inner ear. Right. So you get a mark. They won't be able to vibrate, and you get a mark, it won't be passed to the inner ear or the cochlea or the oval window. Okay? Important question that. Diagnostic report. Which part of the brain will receive impulses from part C? This is an important question. It will obviously be the cerebrum. Nothing else? The cerebrum. Right. That will interpret sound. Questions taken from March 2016, paper 1. Right, the diagram represents a part of the human ear. Okay, you can see what we have here. It's a little snail, isn't it? The inner ear. The diagram represents a part of the human ear. Identify part A. Where is part A? Look, there's a small little round thingy there at the bottom would be the round window. D, the cochlea. That's easy peasy. They will always give you some easy questions and then they will lay down the law with the difficult ones. Hey? And here it comes, the difficult ones. Explain the consequences to the human body if part C is damaged. Now, when you get a question like this, it says, explain. Now, you can't just say it's going to be deaf or the hearing loss. No, you have to say why, because it's explain. So, where's part C? The auditory nerve. So if the auditory nerve is damaged, it won't be able to carry the nerve impulses to the brain, so there will be hearing loss. So impulses from the cochlea cannot be transmitted to the cerebrum. Oh, I said brain. Hey, that's wrong. Cerebrum. Cerebrum. And therefore hearing will not occur. Actually, it's so easy, you cannot believe it. Right. But that's a difficult question. The examiners see this as a difficult question because they are wanting you to explain. Part A becomes hardened. Where is part A? They love this little round thingy here at the bottom, the round window. If that round window becomes hardened, now this is a little membrane, it's hardened. Will it be able to do this? No, it's hardened. It will not be able to vibrate. So it will not be able to vibrate, and it will not absorb the sound waves, and hearing will be affected. Or you can say echoes will be formed, sound will be distorted. Okay. So those are difficult questions, but actually if we look at it, it's not so difficult. Now we finished with hearing, and now we're getting to unit number 3, and that's all about balance and equilibrium. Now, this is one of those slides that the diagnostic report said is important. It's not in the exam guideline, but it's in the diagnostic report. So your teachers were instructed to lay special emphasis on this and to make sure that you know this. So this slide here, extremely important. Take a photo, take a mental photo if you don't have a camera or whatever. Draw it, whatever you can do. This is an important slide. If you know this slide, you can answer anything on balance, okay? So there's 2 ways in which the inner ear regulates balance. So remember now that's the inner ear. The first way is through the crista. Now, what you have to know here is there's a stimulus, there's a receptor, and there's a position where this receptor is found, right? So those three things you must know. So firstly, the stimulus is a change in direction and speed. That's our stimulus. Then the receptor is the crista, and position is the ampulla. It's in those little bubbles at the bottom of the semicircular canals, right? So it's change in direction and speed. It will stimulate the crista, which is situated in the ampulla of the semicircular canals. Now I made a little mnemonic at the bottom here. Direction is D, speed is S, crista is C, A, S. DS cas. Just remember it like that. DS cas. That will be the crista. DS cas. Make a little finger thingy there to just remember it in your head. Right. That is for change in speed in direction. Let's look at the second one. That is change in position of the head, right? And that will be like this. All right, but I'll get into the detail just now. And that's with regards to gravity. The receptors here are macula, and they are found in the Utriculus and Succulus. So position of head, macula, Utriculus and Succulus. And look at the mnemonic there, pimus, pimus. Right, so you've got DS cas and pimus. Right, remember it like that, and you'll be able to answer all the questions. So, both of them ends in the same way. So if you describe this, they've asked you the change in speed and direction, you have to end up in this. You end up in saying the receptor, whichever it's the crista or the macula, right, converts the stimulus into an impulse. Does that look familiar? Yes. With hearing, we just had it now, with hearing. Yes, the same thing again. So what did I say? I said, if you can remember converts the stimulus into an impulse, you get a mark. Whether it's hearing, balance, crista, macula, just remember that sentence. It's 1 mark, people, for free. Take it. It converts the stimulus into an impulse. And it sends it via the auditory nerve, which is also the same with the hearing, auditory nerve. This impulse is sent via the auditory nerve. That's your another mark there. So if you remember that sentence up to there, you get 2 marks. Whether it's hearing, balance, you are settled, 2 marks. To the cerebellum. Now this is where it changes, because this is now to do with balance. Cerebellum, balance. It sounds like balance. So cerebellum, balance. It's not going to the cerebrum here. It's going to the cerebellum. Right. And what's different from sound, hearing, is now that the cerebellum can't just receive the impulse and say, okay, well, I'm going to fall now, and then you fall down. No. What the cerebellum does is it sends a signal down to the muscle, maybe your calf muscles or your leg muscles or your arm muscles, to maintain the balance, to regulate your balance. Right. So that's a different part that's not there with hearing. With hearing, it stops at the cerebrum. You've heard the sound. It's interpreted. You know now that's a little bird chirping. But yeah, it's not good enough just to know, oh, I'm going to fall. The cerebrum is now telling the rest of your body and not sending messages. No messages here. Nerve impulse to the muscle and to prevent you from falling down or to maintain your balance. Right. Remember, no messages. We are not busy with WhatsApps. Please take note of this slide. This is a very important slide for you to know. If you know this slide, you will be able to answer balance questions. Let's get into a little bit more detail. Right, the first one is cristae. Now, I want to make you aware of the E at the back of that word, cristae. The E, if you take the E away, it's crista, which is singular. It means one little crista. But when you add the E there, it's many of them. So the E at the back means plural, many. Right, that's the only difference between a crista and a cristae. Right, but let's get to the picture. Just a little bit more detail for those of you who are curious of how does it work. You do not have to know the detail that I'm going to speak about now, but we'll get to what you have to know. Let's look at the picture here. Firstly, there's the semicircular canals. You should know that part at least. There's the ampulla, and within the ampulla, you will find the little receptors we call the crista. Now, if you enlarge those crista, one crista, it will look like this. There's a little dome thingy there, pointy thing, which we call the cupula. You do not need to know that. And there's liquid within these canals. That liquid we call endolymph. Also, you do not need to know that name, endolymph. When you are standing straight like this little man is standing straight, he's just standing like this, no movement. This liquid will also be standing still, right? But the moment you start turning around, I'm not going to do that because I will fall over, right? But if you look at the pictures there, you will see speed, right? And direction is changing. That guy's going around and around and around, spinning around. That is the change in speed and direction. And that will cause a liquid within this canal to move this little cupula. You can see it's bending over. And as it's bending over, those hair cells there at the bottom are nerve cells. They are being stimulated. And when they are stimulated, what do? They convert it into an impulse. It goes to the nerve, the auditory nerve, straight to the cerebellum. Right. But like I said, this detail you do not need to know. You do not need to know endolymph and cupula and all those things. Right. You just need to know the following. Crista are found inside the ampullae at the base of semicircular canals. Sudden changes in speed and direction causes the liquid within the semicircular canals to move. The movement of the fluid stimulates the cristae, and the cristae converts the stimuli to the nerve impulse, which is transmitted via the auditory nerve to the cerebellum. Right, that's it, people. How easy is that? Let's move to the next point of balance, and that's the macula. Can you see again? We've got an E there. That E is plural. Remember, plural. One without the E will be macula 1. Right. Now let's just look at the detail a bit more and see how it works. Like I said, this part is just for interest's sake. The part that you have to know is on that side. Right, so the macula is found within the Utriculus and Succulents. There it is, in the middle there, in that liquid there. If your head is upright like this little man here, your macula would look like that. There's little crystals there on top. There's a jelly-like layer there, and there's hair cells. So everything is hunky-dory, it's up straight, nothing's happening, everything is fine. But the moment you move your head like this, what's happening is these crystals are now falling over because there's gravity. Right, they are falling over there, and they're pulling this gelatine layer down there with the hair cells. And those hair cells are nerve cells. So what do? Aha, convert the stimuli into a nerve impulse. One mark, tick, there. And that is how balance is regulated by the macula. But let's see how you have to answer it in the exams. Firstly, when the position of the head or the body changes, one mark. The receptors that are affected are found in the Utriculus and Succulus, one mark. They are called the macula, one mark, which converts the stimulus into the nerve impulse. Remember, that's the for free mark. Now, if you don't know it by now, there's something wrong with you. Just know that part. You can get a mark very quickly. It is sent via the auditory nerve, that's also a mark, to the cerebellum, because ballum sounds like balance. The cerebellum interprets it and sends an impulse to the affected muscle so that you can maintain you don't fall over on your face. Okay? And that's how the macula works. So if you know that and you answer it like that, you get your 5 marks. Okay, it's so easy. Let's look at past papers to see how they asked it. All right, this one is adapted. When I say adapted is I took a question, I've added some questions and changed some things because I want you to get to the nitty-gritty of it. This was taken from March 2018, paper 1, and Gauteng Preliminary Exam 2017, paper 1. Okay, if you look at that picture, what does it look like? A little snail, and a little snail is the inner ear. Right, so we are busy with the inner ear. Name the receptors that are found in part B. Now where's part B? The semicircular canals, right. DS, cats, right. You have to remember that. So who's found there? Crista. The crista is found there. Just know your little mnemonic. Describe the role of part B in maintaining balance. So B is the semicircular canal, so they're obviously talking about the crista. DS, Cas. Right, the crista, aha, you get your mark already. In the semicircular canals, ta-da, another mark. Are stimulated by the change in speed and direction, that's the DS part. The crista converts the stimuli into nerve impulses. Again, here's it again. How many times have we said that? That's a mark for free. The nerve impulses are transported along the auditory nerve. Who knew? That's again, how many times have I said this? 1 mark for free. To the cerebellum. Not the brain, the cerebellum. Right, that one was 4 marks, and they're given 1, 2, 3, 4, 5, 6. So any 4 of the 6. Let's get to describe how the succulus and utriculus in the human ear maintain balance in the human body. Now you know, it's not the crista, it's pimus. Pimus. Right, because now they talked about the succulus and the utriculus. So, you have to talk about the macula. Ta-da, 1 mark. But can you get a mark for utriculus and succulus now? No. They've given it in the question, there it is. They're not going to give you marks for that. They've already said that. So, no, you're not going to get that mark. It was mentioned in the question. But you're going to get for the macula. Are stimulated by the change in position of the head. P, that's where the P comes in pimus, right? Position of the head, 1 mark. Ah, here we go again. The stimuli are converted into nerve impulses, 1 mark. Transmitted via the auditory nerve, 1 mark. People, after this lesson, you must know those 2 sentences. To the cerebellum, 1 mark, which send impulses to the muscles, enabling the person to maintain balance. So this is also 7 marks, but it's only 5 marks. So 7 ticks, 5 marks, any 5 will be accepted. Right, so we finished with Unit 3. Now we're busy with the last unit, and that is the unit on diseases and disorders of the ear. Now the first disorder is a horrible disorder, and that's called middle ear infection. Oh boy, if you had this, you would know you've had it. It is extremely painful, right? It is really terrible. It's caused by bacteria, and what happens is this bacteria infects your middle ear, and all this liquid and pus is forming inside your middle ear. And if you look at this diagram, this poor Eustachian tube is swollen with inflammation. Look at that inflammation there. What happens is your Eustachian tube is swelled closed, is closing up of all the swelling and inflammation. So then you have a problem because now all this liquid is stuck inside your middle ear, and it's building because more and more liquid is forming. So what's happening to that poor tympanic membrane of yours? This liquid is now pressing on it, pressing in it, and this poor thing is bulging outwards, and it's hectically painful. What they do is they give you antibiotics. So you need to go to the doctor to get antibiotics, and that will kill the bacteria that causes this inflammation. And the moment that bacteria is killed, the liquid will stop forming, and the inflammation and swelling will go down so that the Eustachian tube opens up, and that liquid can drain out. You can equalize your pressure again on both sides of your tympanic membrane, and you're sharp again. But there are those few those poor individuals, and mostly are children, small children, but there are some adults also that suffer from chronic middle ear infection. Now, I must tell you, I feel very sorry for those parents. Imagine that screaming child. This child is screaming for pain. It's hectic. He's screaming, screaming. Nobody's sleeping. It's horrible. So what the doctor usually does is after antibiotics course, they put in a grommet. What's a grommet? A grommet is something like, it looks like a little button, but it's a little plastic tube. And it's so small. This looks big because the picture is big. This is actually your eardrum, the tympanic membrane. And that's a very, very, very small plastic tube. It's done through surgery. You can't just sit there in the doctor's room and they pop it in. No. It's surgery, right? And this works in 2 ways. Firstly, it will provide a space for the liquid to drain. So the liquid from the middle ear can drain into your auditory canal and it can come out here, right? So that pressure that's building up can be released, right? Secondly, it also enable you to equalize the pressure on both sides of this tympanic membrane so that your tympanic membrane doesn't bulge the whole time and it's painful, right? So these grommets are put in, It usually lasts between 6 and 12 months, and then it just falls out. And that hole that they make into your tympanic membrane is so small, it doesn't affect your hearing at all. Right, so you'll just sleep and pop, it pops out, and that's the end of it. Right, so that's a grommet. Wonderful thing for some parents. Right, now we get possible causes of hearing loss. Now, the first one is hardened earwax. Now, this is a horrible thing to happen. Sometimes it happens when you take these earbuds and you fiddle too much in your ear. That's what happened to me one year. And I had it's like a plug that forms into your auditory canal. And it plugs the sound waves, so you can't hear nicely. And I had to go to the doctor's room where they had this water funnel. They sprayed it out with pressure, water pressure. They rinsed it out. Right, so this hard pieces of wax came out and I could hear afterwards. So it's a temporary thing. It can be cured. It's not the end of the world. You just need to get to somebody that knows their thing. Do not do it yourself. Do not put in sharp things there and try. Just now you hook out your tympanic membrane. That will be disastrous. Okay, so don't do it yourself. Go to a doctor or clinic. Right, this one is a ruptured tympanic membrane. That would be somebody who tries to take this out himself. Right, it will look like that. Those are holes within the tympanic membrane. This was actually taken from a guy that loud noise at his wedding. It was a fireworks explosion. And that sound was so loud that it burst his tympanic membrane. I can just imagine the pain. And obviously you can't hear because how can it vibrate now? So loud noises, if you're in a car accident, maybe it can burst. If you deep dive in the ocean without equalizing, then this will happen to you. Right. Damaged ossicles, we spoke about that. That's when they are fused and they don't want to move and vibrations cannot be carried forward. Damaged cochlea, that's usually happening to older people. Your hair cells seems to die off in your cochlea and the sound, you're hard of hearing. It also happens to young learners or children who sits with earphones in their ears the whole day with the sound way up. You're going to be deaf, my dear, by 30. I'm warning you. Damage to the auditory nerve, that unfortunately is a very bad and very serious thing. If that nerve is damaged, there's not much they can do for you. The same with brain damage. If you're in a car accident or you had brain damage in your cerebrum, there won't be anything that they can do for you to fix that problem. Right, but let's look at how do they cure or how do they help these people. Firstly, in the old days, they had something they called an ear trumpet. I'm just going to try and fold this for you. Okay, they had ones made of steel and iron and stuff. It was shaped like this, like a little cone. Right, so it's a small surface area and a big surface area. Does that remind you something? Right, the ossicles, or the tympanic membrane and the oval window. So they used to put this into the ear and say, huh, what did you say? And then the people had to speak in ear. Right, so it amplified the sound. Right, that's the ear trumpet. But luckily, technology came along. Hallelujah. So now we have hearing aids. And a hearing aid is something you can put, you get small ones, you can put it inside your ear, or you have ones like, if you see this photo, this little boy is wearing it, it's like around his ear. And what it has is got a little microphone that's catching, receiving all the sound waves. In there, there's an amplifier. Now, remember what I said? Amplifiers making the sound bigger, louder, and that's what the amplifier does. It amplifies the sound. It makes it louder, right? And then the speaker then directs this louder sound, this bigger sound waves into your ears so that you will be able to hear it, right? That's hearing aids. But if a hearing aid does not work, and also you don't need to know how it works, for that you also don't need to know. We'll never ask you how does a hearing aid work. You just need to know that hearing aids are used. Cochlear implants, that is when a hearing aid doesn't work, right? There's more damage to the ear. Then what they do is they implant it into your ear, and you usually have a sound processor on the outside, like you can see in that photo there. That will receive the sound, and it will convert it into a digital sort of code, right? And that is then sent to the internal implant. It's inside the bone, inside in the inside of your head, right? That converts it into electric impulse. That electric impulse is sent via electrode. That's extremely small wire because it fits into your cochlea. So it's so small that you can just imagine the precision that the surgeons have to work with. They coil that into your cochlea, right? And what happens is that electrical signal is then sent into the cochlea, and that converts it into a nerve impulse that sends it to the brain. So that's how a cochlear implant works. And now we're getting towards the end of the presentation. These are questions from past papers on the ear defects and illnesses. This is taken from paper 1, November 2015 and 16. I combined the two. Explain why people with middle ear infections, which we spoke about now, are usually advised not to travel by aeroplane. Where did we speak about an aeroplane before? Eustachian Tube, isn't it? So you need to know that if you have a middle ear infection and you go up in an aeroplane, boy, you're asking for pain. Right, so if you have a middle ear infection, there can be mucus or liquid in the middle ear. That's one mark. That will lead to a blockage of a Eustachian tube, or it can be swollen. The Eustachian tube can be swollen, shut, or it's blocked, right? Which will not be able to, and here we get to the crux of it, equalize the pressure on both sides of the tympanic membrane. So the pressure can no longer be equalized, like I said when we were busy with the aeroplane, resulting in pressure on the tympanic membrane. So there will be a lot of pressure on it. It will bulge outward, right? And that can even cause it to burst. Imagine that, flying in an airplane and your eardrums are bursting. And that leads to hearing loss. Right, so it's 1, 2, 3, 4, 5, 6, and this was 4 marks. So any 4 marks is correct. Describe how an increased production of mucus in the nose and throat might lead to bursting of a tympanic membrane. Here we again go towards the Eustachian tube. And if you have a lot of mucus in the nose and ear, what will happen to the Eustachian tube? It will be blocked, isn't it? So just think along those lines. The mucus will block the opening of the Eustachian tube, and now air can't be going in or out. Right? Can't. So no equalization of pressure on either side of the membrane will be done. There's your 3 marks. Or if you said that mucus in your throat can go up into the Eustachian tube, into the middle ear, that buildup of mucus causes pressure, so it's more pressure, and that will push the tympanic membrane. So they, you know what, they allow for more options, because this is taken from the paper. They allow for people who think in different ways, because both is right, both is correct. So if you've taken it from the way that the mucus will move up into the middle ear, that's fine. Or if you just thought about the Eustachian tube will be blocked, that's also fine, as long as you can explain it. Right, so that is, we've come to the end of this presentation. I just want to do a little recap on what we've done. Firstly, we've learned that the ear is not only this little flap here on the outside, that according to your parents doesn't work. No, it's much more than that. You've got 3 regions, the outer, middle, and inner ear. You've got a pinna that directs the sound. You've got an auditory canal there. You've got a tympanic membrane which vibrates. You've got your middle ear with the ossicles, those small little bones that will carry the vibrations into the inner ear via the oval window. And that blue there is your inner ear. Those are the semicircular canals. Your Utriculus and Succulents are there in the middle. That's the cochlea that carries the organ of Corti, your receptors for sound. Your receptors for balance are carried within the semicircular canals. Dies cas, and P-mus is here in the middle. And the cochlea has got the organ of Corti. What's the important sentences you must remember? It will convert the stimuli into nerve impulses and carry it via the auditory nerve. If you know that, you've got 2 marks already. Right? The Eustachian tube, they will ask things like middle ear infection there. How will you equalize the pressure on both sides of the tympanic membrane? So you have to think along those lines. And that is it for the ear. People, please just remember to study your structures, your labeling, your functions, and remember there's a hearing and the balance function of the ear. Remember the 2 illnesses that we've spoken about, and that's all from me. Thank you.